Now I am going to present you a historic project, that is this Tallah Tank. Before going into that, I was just discussing with Abhinit why you are allowing me to present this type of structure, because it's a 100-year-old structure, and if I go on retrofitting the structure and rehabilitate the structure, then what will SAIL do and what will Tata do and what will other manufacturers do? We are retrofitting this, we are keeping this, we are enhancing its life. At least for Tallah Tank, we are predicting more than 50 years. But my answer is very clear that here in India, I will come later in my presentation, we have so many old structures, and old steel structure is not iron structure. Steel structure, so many steel structure like Tallah Tank. In Kolkata, we have a very beautiful two structural wonder is here. One is Howrah Bridge, one is Bali Bridge. They are full steel structure. Bali Bridge is 90 years old, it's constructed in 1930, and Howrah Bridge is 1943. And it is a world-class structure, but the problem is that, I get back my own question that why I am presenting that, we are sometimes miss this structure to evaluate what actually, these are all real life experimental evidence you can get from it. So it's a real life structure, it's a real life experiment which is not done in our university lab. So we are not getting out all these things, whatever the speaker said, that steel is durable. What is the evidence? This is the evidence. Steel is very much ductile. It can take wind load, it can take earthquake, shaking, it can take so many other loads for hundreds of years. So it is an evidence that steel is ductile. So these are the things which we require to make other structure also, and also I request the steel manufacturer also, they will support the thing. We have Mr. Varma from RDSO told that they have thousands of old bridges, steel bridges. We have just rejected recently that bridge near Noihati, that Jubilee Bridge, but I afraid that it was not evaluated properly. It was rejected, new bridge came, but it was not evaluated properly. If evaluation can be done, then our whole statement could have get a clear evidence of what is steel. Further going into the Tallah Tank, I will say that is very interesting for my designer friends also. A recent research in university we are doing something about that. It may be known to anyone, but one of the most important property of steel is something beyond what we are discussing. If we compare steel and concrete, then steel has a very big advantage for us, because the steel, when strained, when deflected, when deformed, steel gains strength. When concrete deformed, concrete strained, concrete deflected, concrete softened, steel hardened. This is the basic thing. If you see the curve of steel stress strain curve, you will see a peak, that is a strain hardening peak. You cannot get that peak in concrete. So in today's research area and today's in our practicing engineers, we always believe the structure should not fail. It should have a reliability. And that structure should not fail means it can respond properly in non-linear stage also. At the failure time, it can respond, it can fight against the failure. For the steel, this non-linear stage, it has got the ductility, it has got the high strain hardening aspect. That aspect is most advantageous for steel, and the chance of failure in that way is much less of concrete much less than the concrete. So steel has a very reliable material in that way also. And this has been actually, this is the relevance of today's my topic, this Tallah Tank. And Tallah Tank is, you know, the 100 years old, and it is a 10-12 kilometer from this place. And it has performed beautifully last 109 and 110 years. Actually, and the owner of the Tallah Tank is KMC. Mr. Pal is here. Actually, a team has done it, not me only, not Mr. Pal. A team had made this possible, and everyone, whenever we have gone to January earlier for the project, so everyone said, why you are keeping this? It's 100 years old. Leave it, get rid of it. But we took the challenge, and now a part is completed, you know, it has came in the press, and it is now again built up for next 50 years at least. So this is the Tallah Tank, and this is, you can see. This is a history. You can see, this is in 1909, the first corner trestle was just put on the foundation, and in end of 2011 it is completed. This 8,000 steel work is completed within 2 years. Other than and complete work has completed within total work including foundation was completed within 3 years. So it is another thing, is another proof for steel what we are saying, what we have been listening from the morning, that accelerated construction is steel is the most favorable for accelerated construction. It is the proof. 1909, 2012, 7,500 ton steel work has been done, and it's a riveted work. Riveted work takes time more than welding. It's a riveted steel tank. So this is a beautiful history. And before going into the next slide, I am telling you, this is steel. Steel in a sense, steel. It is not iron. Eiffel Tower is wrought iron, not steel. So many other structure is iron, not steel. So it is a steel, and it is a all steel structure. Sometimes my last speaker told that column is cast iron, roof is steel. It is not like that. It is the first complete steel structure maybe in the world. It is not properly written history. It is maybe in the world. And first steel brace frame structure, you can see the bracing. You can see the bracing. So this is a simple for you. This is we have got. So you can understand the big thing, how big a structure it is. So today's relevance, that is what I have already started to say. Today's relevance, this big structure, I just go to the next slide to show you the figure of this. This is the structure. This is the structure, and you can see this is a brace frame. And this is a load-bearing brace frame, not Eiffel Tower brace frame. It's a load-bearing brace frame. There is a 6 meter height of water above, 5 meter height of water above. So this is the first of its kind in the world. As far as our history, we have searched the history. So this base frame is basically can give us a handful of evidence for a steel building. It's 100 feet height. We are working with steel building, which is more costly. Concrete building is more costly, or steel composite building is more costly. So this is a genesis is here. So this is the brace frame, you can see. And interestingly, my friends, consultant friends are here. You can see this is a very normal frame. In American code, you can see there are two types of bracing. One is nodal bracing. There is this type of bracing. Other is relative bracing. This is this type of bracing. Here you see, is not that type of guideline, taking a guideline and then the bracing was designed, not like that. It was just, I have seen, only Euler's formula was used for this design. That is slenderness ratio. And it is a type of bracing, and we have to research on that, this type of bracing where there is no, you can see there is no horizontal member. So this is a bracing, and this is, and not only in the superstructure, it has a huge steel. I think 7,000 steel is in the top and 2,000 steel in the foundation. It's a grillage foundation. It's a complete raft with embedded grillage foundation. Joist after joist is there, and so it's a big grillage foundation that may be 2,000 ton in a buried condition. So there is a 4 compartment. And this is, that I was explaining, that this is the actually our relevance for this today. The relevance is, this is a satisfactory performance, and satisfactory performance is one of the evidence for any structure. It has got a redundancy in the structure, that is very important. Redundancy means it's a well spread structure, and it has got a robustness in the structure itself. It's a structurally integrated, and you can see the bracing system has got not only one plane, it has got a both plane bracing. Just in towers, when you design the tower, we have a vertical, that is plan bracing. Here also the plan bracing is there. So it's a highly braced structure. As you see the Howrah Bridge, highly braced structure. That was the, I think that may be the rules of that day when this was highly integrated bracing system. And that helps to perform this structure for 100 years. So in steel design, as a designer, we have to learn how to integrate the structure so that it cannot go for the progressive collapse, it cannot go to the disproportionate collapse, it cannot go to the failure area, sudden failure. So this type of integrated structure is another example, can be evidence of example can be taken out. So now I just go to the, that is the area where the steel has got another important thing that we should not ignore. That is, steel has got a finite limit in fatigue. When there is the bridge, here is some bridge people there designing the bridge, they know this thing, that this Tallah structure is actually 90 million gallon. And I think, Amitabh, what is the total daily movement of water? 45 million gallon of water is handling per day. So filling, emptying, and there is a sorry, there is a turbulence inside also. So we better to call it a quasi-static structure, not a static structure, it's a quasi-static structure. And this type of quasi-static structure has got the chance of dynamic behavior, and structure has to responded to the dynamic behavior of the load, number one. Number two, it has got a wind force continuously, because you know the area is high wind zone. So for that wind force, there is a chance of wind fatigue. There is a recent research area. Wind fatigue is there. So for this, yes, I have one. Please. So I think that this wind fatigue acted here for 100 years. And I have given some example for that also. And for that wind fatigue, the structure we have not seen, we have 1 year, 6 months we have evaluated the structure, but we have not found any fatigue crack, any growth of fatigue crack, any propagation of fatigue crack, nothing we got. So it is also important that the steel has got a, you see, in theory, the steel has got an infinite fatigue limit. After some time, there should be no crack in the steel after some cycles of loading, but not in aluminum. Only steel and titanium has got this particular capacity, it's a nature. But now the researchers saying that no metal is out of fatigue. Every metal can have a fatigue. There is no infinite life, there is no endurance. But Tallah Tank is giving us something different. Tallah Tank, its experience, its evidence is giving us something different. So it's a big research area. The people who are research metallurgists who are researching with this, that no, there is no fatigue limit. After some cycle, we say, earlier we say that there is a fatigue limit. After that, there is a structure is free for fatigue crack. But Tallah is saying that, this evidence is saying that, but now the new area is telling all the metals are bound to be fatigue after some cycles of loading. So this is a very important thing that also a research area and also the manufacturer, they also give some light on this very important area. So what is our challenge? When we get back to Tallah, what is our challenge? There is evolution of present state of the structure, aging, deterioration, etc. Past performance evolution is one of the very important things, but the data was very, what I say is the data was very few, and but we have seen the history of earthquake, history of wind, what actually the structure has been responded for that. And most important, the restorability of the material. It is iron or steel. If it is iron, no weldability. But if it is steel, then it had got the weldability. If weldability is not there, we cannot renovate it. We cannot put bolt on it. It's a riveted structure. So first thing, we have to take, the flame test. Different flame are coming for cast iron or wrought iron or steel. So we have to take the first is a very simple test, and we got that no, it's steel. If all the member is steel, plate is steel, rivet is steel, maybe slightly different, sections is steel. So it is a something which I got that it is possible to restore. So we first identify the material, and then testing and was done, and restored the structural system. Next thing, whether structure is highly redundant or not, structure is highly robust or not. If it is not, then it is not possible to extend its life. These are the few things which always we are, I think the designer must know which structure can be restored. Some points are there. So this is an important point. And the constructability, because Mr. Pal is not allowing us to close it down. KMC is not allowing us to close it down and repair. We have to keep the operation at least 75%, then only we can do the structure rehabilitation. So it's another challenge, how to rehabilitate this structure, because we have the 4 tanks we have seen, one at a time we targeted and we are completing one at a time. So there will be not much operational disturbance during our execution. This is the structure, and the most interesting part of this structure, here is a timber plank separation of staging and tank. This is the timber plank. Just below the tank. And you will be surprised to know the tank is not rigidly fixed with the staging. This is very important, this type of structure, but it is seated on a staging where it is just seated, and the timber is, the viscoelastic property of timber, and it has got a damping of vibration and everything. Finally, time is up. So this is the situation of degradation, deterioration, and then you can see the plate deformation inside the tank. Roof of the tank is deformed, and this is the past performance verification we have done, the earthquake this load has been taken. This is a wind load, this has been taken. And this is a material testing report which is sometimes similar to today's steel, is not very much difference. And that is the advantage for our to go with this. And then we go for the structural stability system identification. What is the structural system? Actually, what I was discussing, and there is a system identification and a timber damping property provides the resistance to low cycle, earthquake, other thing, it given a property. We have a paper on American Society on this damping property and separation of the structure between the staging. Now we are separator giving in the foundation, but this separation is in the top, that is in the within the. So this is the torsional bracing, the planned bracing I was talking about. So it's a highly rigid, this type of individual frame. And this is the repairability of the structure and the basic inadequacy. This was the basic inadequacy. Mainly corrosion and deformation in plates is a main inadequacy. So we have just made it in that way, and you can see in the, this is actually our, we have stiffened the bottom plate, is not fully stiffened. We have stiffened the bottom plate. We have strengthened the ties in the stays. You can see the stays. These are stay in the wall. That stays were deformed in that way. It is deformed, but we strengthen it. And whatever the main thing we have done, that we have made the bottom plate of the tank is a sandwich plate. We put concrete on that because you know it's a riveted plate. We cannot put something on that. We cannot weld it because welding near rivet should not be done. Rivet may be loosened. So we put the concrete over that and put another plate and make a sandwich, and for that, which will give us a very important thing, there's a whole diaphragm action against the wind. So we make a thick plate here. You can see the concreting is done in the bottom, and we make another plate over the top. Just over the top we plate, another plate we have given, and after stiffening of the thing. So this is a lesson learned, what I have already told you. So many lessons are there, I don't know, I only learned something, but if this type of structure can be properly investigated, all the old structure, we can learn something which we can say in this type of forum with the evidence of this structure. This is the most important thing, and that is we require a joint effort from all concerned, from the manufacturer side, from design engineer side, design practicing engineer side, and from the user side. So this is very important so that we can interpret the steel structure properly. We should not make a museum of the steel structure in India because we have so many old steel structure, colonial structure. So we have to recognize that, we are using that, and if we are to make them obsolete, please obsolete it, but before make it, evaluate it properly, and then obsolete it, and we learn something from the old steel structure. Thank you.